G'day, I'm Jacob from Make Science Fun. Thanks for joining me today. In this video, I'm going to be doing the world's smallest science show. I'm very excited. We're going to be making gummy bear soup. We're going to be dissecting a party popper. I'm going to be doing water push-up. I'm going to be doing what I call mouse's toothpaste. We're going to do swimming sodium and calcium carbide. Kaboom! So I hope you enjoy the world's smallest science show. So we're going to start with gummy bear soup. The first thing I need to do is turn on my Bunsen burner and light the match. Now I've got a tiny little beaker here. It's a 10ml beaker. Now I'm going to put a gummy bear in. Which one shall I choose? I might choose the yellow one to start off with. There we go. No, not the gummy bear. Let's put him in. And straight away he starts to sizzle and smoke. Now, sizzling, he's changing from a solid to a liquid, and that's a physical change. Physical changes occur when there's a change of state. He's almost all liquid now, so I might add the next one. Green. Let's go green gummy bear. No, in you go. So I've got a yellow and a green one. The yellow is like bubbling up all around the green gummy bear, and the green one's starting to change shape. And if I waft it towards me, I can smell something new. There's a chemical change happening as well. So, bubble, bubble, bubble. How about we pop in the red gummy bear? Oh! So I go bloop, bloop, bloop. Let's go blue. Let's pop him in, and he'll start melting almost instantaneously. So let's keep going with the others. In you go, orange. No! And then finally, let's put the... Oh, well, this one's almost colourless, isn't it? Let's pop him in. I'm going to put this probe in, and we're going to see what temperature it is in this soup. Let's find out, shall we? I'll pop it into the beaker with the soup, and very soon we'll see the digital display going up. It takes a little bit of time for the temperature to register. Wow, 85 degrees. Whoa, 103 degrees. It's got a higher temperature than what water boils at. And that's because it contains a lot of sugar and quite a few other chemicals as well. Woo! Let's get that out. That's definitely a goopy chemical reaction there. That's how we make gummy bear soup. I wonder what it tastes like. All right, burning iron. Now, iron is a metal, and you use it to make nails, and I'm going to light this Bunsen burner, which is actually made out of iron, and here's a rusty nail, which is iron coated with iron oxide, but it won't burn, will it? It will maybe heat up a little bit. This wire gauze is also made up of iron, and as I heat it, we'll actually see that it will start to glow. It will glow orange, and that orange actually depends on the temperature at which it's glowing, which is probably about 600 degrees Celsius, something like that. Can I make iron burn? And the answer is yes. I've actually got some steel wool here. It's tufts of iron, very, very, very thin. And so let's see what happens if I put this steel wool in. Whoa, look at that! I think I'll put some goggles on. Now, what about if I burnt it in pure oxygen? What do you think would happen? Well, I can actually make some oxygen. In this little conical flask, I've actually got some hydrogen peroxide. Now, hydrogen peroxide has a formula H2O2. Now, you might think that looks a whole lot like water, and it does, because here's water, H2O. But this one's necessary for life, and this one, if I drank it, it would literally kill me. It would bubble down my throat, causing it to blister and burn. This is very concentrated hydrogen peroxide. If I add some manganese dioxide, I can actually split the hydrogen peroxide into water and oxygen gas. So I'll pop that in, and we see bubbles. We see bubbles of gas straight away. Now that bubbles of gas is oxygen. And you watch. I'm going to put the iron oxide. Look at it burn when it goes in the oxygen. Look at that. Let me do some more. Are you ready? In goes the oxygen. Whoa, in goes the metal into the oxygen, and it burns super, super bright. Wow, I've got some magnesium ribbon here, and I can actually cut the metal with a pair of scissors, and this is going to get super, super, super bright. Let me put it in the flame like this, and are you watching? Look at that! Look at that! I don't dare putting it in the oxygen, but it actually produces, when you can actually see it, it produces a white powder. There's a chemical reaction because a new substance, magnesium oxide, is formed. And here it is here, this white powder, magnesium oxide. Magnesium oxide, the white powder. And you can use this magnesium flares to light up the sky. Whoa! So if you're looking for someone who's lost at night, you can find them in the dark. Look at that. Woohoo! And so, you might have heard of the very popular chemical reaction called elephant's toothpaste, where they add chemicals and the foam shoots up out of the beaker. Well, today we're going to do mouse's toothpaste. Mice are small and don't need as much toothpaste, but it's a very cool experiment. And so I need to get the Bunsen burner going because I need to actually heat up the chemicals. When you heat up the chemicals, it actually causes the chemical reaction to go quite quickly. So I'm going to start heating up the hydrogen peroxide, and to this volumetric flask, the first thing I'm going to do is I'm going to add some water. So let's get some water in there. Shake, 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 shake that water in. Tap, tap, tap away. That's about right. And then I'm going to add some potassium iodide. Now this potassium iodide is the catalyst for this reaction. This is what's actually going to split that hydrogen peroxide up into the oxygen and water, and it's that oxygen gas which is actually going to, it's that oxygen gas which is actually going to cause the bubbles to go up. And so I'm going to put in some liquid detergent. In goes the liquid detergent like this. That will hold the bubbles quite well. I've got some red food colouring. I'm going to pour down the side here. One drop there. And how about one drop on this side? Nice. Are we ready for mouse's toothpaste? Ready, set, go. Wow! Look! Whoa! 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 Oh, look at that! That's like rat toothpaste. Woo! It's like a giant ice cream steaming cone. Now this is an exothermic reaction, and so a lot of heat has actually been produced here. Wow! And this is like steam. Not a lot of colour. maybe I need to add a bit of colour to finish it off. That's not working that well. What about a bit of blue? What if I drag up the blue? Bloop, bloop, bloop. Does that look like toothpaste? Not really, hey? But anyway, I certainly gave it my best shot. It was a little bit slow to get going, but once it did get going, woohoo! And so the hydrogen peroxide molecules were broken down by the catalyst, potassium iodide in this case, into oxygen gas and water. And it was a very exothermic reaction. Lots of heat and lots of oxygen gas was produced, which caused the bubbles to shoot up. How good was that? I love it. Mouse's toothpaste. All right, this demonstration is called the steaming tower. And for it, I need to have some liquid detergent, and I'm going to just add a bit of water to that to make it a little bit less viscous. It's a little bit sticky. Mixy, 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 mixy. Add the catalyst, the manganese dioxide, to that like so. So tip that in and mixy, mixy, mix him up. Pour that into this 5mm measuring cylinder. So hopefully that will go all the way to the bottom. That's perfect. And now I'm ready to add my hydrogen peroxide. Now this is 35%, it's very concentrated, so let's see what happens. This is called the steaming tower. Here we go. Oh, it's a little bit runny. I'm not used to being that runny. Normally I'm used to being a little bit thicker. Will it thicken up as time goes by? Ooh, we will see, we will see. Let me turn it around a little bit more. I'm not all that happy with that one. I've seen a lot better. It's starting to come up. I think I needed to add a bit more manganese dioxide to it. Oh, it's sort of satisfactory. It's steaming, that's for sure. It's a little bit like the elephant's toothpaste, isn't it? I might try that one again. Let's see. So it's going up a bit slower this time. It's going up a bit slower, but it's rising. And yes, this is closer to what I want. And it's got a nice black stripe on it. That's exactly what I wanted. Better? I think I can do better than that. Yeah, let's try another one. Third time. What will this look like? Oh, up it goes. Oh, whoa, whoa. You know what? I think I preferred this. Whoa, look at that. I love that black stripe. All right, that is the steaming tower. Hey, it's party popper time! Have you seen these before? They're little plastic containers and they've got a string like this. And when you pull the string, woo! Explodes out and smoke comes out of it. How wonderful is that? What do you think is inside a party popper? Let's cut off the skin like this. Whoa, there we go. So let's remove the skin. The skin holds in some of the guts. And then what I notice here is a piece of cardboard with some warnings on it. They probably say don't point at your face. And I should be able to remove that cardboard. There we go. So remove the cardboard. Whoa, and look, some of the guts have come out. Here we go. Oh, look at this. They're little rolls of ribbon. See that? Rolls of ribbon. I can undo the rolls. So when they fire out, they unroll and they go shooting through the air. Woo! Like so. Use my scissors to like really cut him open. So here we go. Snip, snip, snip. And let's pull that plastic over his little face. And oh, there's another piece of cardboard. So that cardboard explodes out like that, pushing out the guts or the ribbons. And but what actually causes the explosion? I see something there that looks quite interesting. I might put my tweezers there. Can you see that? Can you see in there? Can you see how there's something white there? And I'm going to put the tweezers there and I've got to grab it. And I'm pulling it out. Look at this. Pull it out, pull it out. I've got it. Okay. That's the explosive charge. There we go. So I'm going to put my goggles on and I'm going to light my Bunsen burner because I'm going to ignite this charge and see what happens. Let's find out. Bunsen burner on. And are you ready? I'm going to hold it in the flame and let's see what happens. It's burning. It's burning. Whoa! Whoa! What an explosion! Woo! Oh, I bet you want to see that again. Whoa! Whoa! Let's see if you can not blink. Let's see if you can not blink when I do it. Here we go. Let's see what happens. Oh, wow. Oh, I hate that. Okay, so this demonstration is called swimming sodium. Now, sodium is a very unusual metal. I've got it here. It's got this clear, colourless, goopy stuff, which is oil. You actually have to keep sodium in oil because it's so reactive in air. Now, I've got my little pocket knife, and I'm going to cut that sodium in half. It's very soft metal. I can actually cut it with a knife. Look at this. Cut it with a knife, and when I cut it, you can actually see it's got a silver reflective it's got a silver surface. See that? It's got a shiny luster when freshly cut. That's a property of metals. Why does sodium have the symbol Na on the periodic table? Why not S? Well, S is taken by sulfur, but why is it Na? Because the Latin name for sodium is natrium, and natrium means swimmer. I'm going to cut a small piece of this and I'm going to put it in this. I'm going to put it in the water that's on this watch glass. Now I'm just going to add a little bit of universal indicator because we might get a colour change as well. Very important that I put my safety goggles on for this because this produces hydrogen gas and it's a very exothermic reaction. Exothermic enough that it could actually explode. Okay, goggles on. And then I'm gonna put it on the water and then get back. Oh, there we go. It starts reacting straight away. Oh, it goes into a ball. Oh, swimming around the surface. See how it's swimming, a little spark? See how it's swimming around the surface? Whoa, whoa, yes, look at that. Look at that. Oh, wow. The heat from the flame caused the sodium to actually melt. Whoa, and there was a little explosion there. The heat from the flame caused it to melt and it went into a sphere, and that sphere swam around the surface of the water, and that's why it's called natrium. Oh, how good was that? Let's have a look at one in slow motion. So it's fair to say that I actually don't like the calcium carbide Kaboom. Calcium carbide I like quite well. Here it is, there's a little plate of it here. It's like a little white rock. I might put a chunk of it in this conical flask with a bit of water, and look at it bubble. Look at the bubbles forming there. That's actually acetylene gas. And if I put this rubber stop on with the tube, I'll just put my goggles on just to be safe, just to be 100% safe, I can actually, let's see if I can actually light the gas that comes out. Whoa, look at that. It's beautiful. Blow it out. Let's light it again. Woo! What about, I wonder how far the flame, wow. Look at how far the flame jumps. I'm putting the flame, wow. That jumps a really long way, doesn't it? Wow, that was like 5 centimeters. Can be hard to blow out. That's better. Now, to get the calcium carbide Kaboom, you need to have the perfect amount of acetylene gas mixed with the perfect amount of oxygen, and then you need to light them to get a Kaboom. And I'm going to try and do it in this little pan. To get my oxygen gas, I'm going to use my hydrogen peroxide. I might put the little chunk of calcium carbide in the pan, clink. Then I'm going to put in the hydrogen peroxide, and there's already some bubbling happening. And if I add a bit of manganese dioxide, oh, I'm getting all sorts. Whoa, there's a lot of gas being produced there. I'll put on the lid, and how about I light it, and we'll find if anything happens. Nothing. Little flame. The little flames. You can just see the little tiny flame. Will I get a Kaboom? I don't think so. No Kaboom. The calcium carbide Kaboom is hard. It's difficult. It's a very difficult chemical reaction to occur. Let's put a bit of chunk in here. And I'll get my match ready and my lid ready. Okay. Alright. Let's see. Let's try. Come on. Gas. Lid. Whoa, that's not a Kaboom. That's just lots of flame. Oh, No, that's not a Kaboom. Okay. Alright. It's just... Okay, a bit more hydrogen peroxide. Lots of oxygen. Oh, just not getting the right mix happening here. Oh, there's a big flame as it goes in. Oh, sometimes as the flame goes in, sometimes it might go boom. But I don't think it's going to be. Not everything always works as anticipated in science. I hope that one day you get the Kaboom. Oh, well, we're going to have to go back to some footage that I've made another day to see this Kaboom. Get our bubbles, get our thing, light our thing, and let's see what happens. And let's see what happens. Whoa! Oh, wow. That was crazy. Boom! Well, that was the calcium carbide Kaboom. Alright, last but certainly not least is the water pump up. One of my favourite demonstrations of all time. Now, I've just got some water coloured with a little bit of yellow food colouring here. And I'm going to heat it up. There'll be a physical change as the water goes from a liquid to a gas, as it evaporates, as it boils. Now, what do you think's in the conical flask at the moment? Well, there's a little bit of water, there's a little bit of food colouring, and there's a lot of air. I hope you didn't say nothing. There's a lot of air, and what's actually going to happen is that steam, the steam when the water boils, and it's actually starting to boil now. It doesn't take long. This is actually, all this smoke is actually, there's a little bit of, all this smoke is actually coming from the wire gauze. I think there's a little bit of oil on it or something like that. It doesn't normally smoke like this, but what we'll see is a bit of steam. See a bit of steam. Woo! Can you see the steam coming out of the glass there? Look at that. I can see this. Oh, I've blown out the flame. There we go. There's a bit of steam coming out the top there. And so the steam is actually pushing out all the air and filling up this conical flask with water vapour. Now I'm going to flip it upside down. The water vapour will cool and actually will form a vacuum. And then air pressure is going to push that water up into this flask. Now it happens really, really quickly. Are you watching? Here we go. Watch. Wow! Look at that! Wow! Wow! The water got pushed up, wow, into this flask. That is absolutely amazing. Well, thank you so much for joining me on this world's smallest science show. I hope you've had as good a time as I've had. There is a worksheet available, and you can go to the description in this video to the link in order to obtain this worksheet. It's a beautiful worksheet, and it's got all the demonstrations that we did today. So thank you so much for joining me. If you like that video, make sure you do the old subscribe and notification, ding dong, and all the rest of it. And I'll see you guys again soon.